Once again, welcome to our Cooled Care Maths class, and today we are going to learn about the first part of mensuration, and in this part, we will focus on perimeter and area, and if you have any question or any comment, just feel free to type it in the comment section. So, from the definition, mensuration is the branch of mathematics concerned with the geometric properties of figures, such as length, area, and volume. It provides the fundamental tools for quantifying the size and shape of objects in the real world. Also, since we will discuss about perimeter and area, let me also define them. So, perimeter is the total distance around the outside boundary or edge of a two-dimensional shape. In short, we just say distance around a shape, and area is the measure of the space contained within the boundary of a two-dimensional shape. Now let us start by the perimeter of a triangle. Suppose we have our triangle A, B, and C in capital letters, with also the corresponding sides A, B, and C in small letters. Then we add another line inside the triangle, which we can just call D. We can now determine the perimeter of the triangle by adding only the external sides of the triangle. Hence, perimeter is equal to A plus B plus C. And take note that, when calculating the perimeter, we do not include the lines which are enclosed inside the triangle, for example line D. So, we should only consider the lines which forms the borders of our triangle. Let us do a quick example to make things clearer. Suppose we have our triangle A, B, C, with sides 5 centimeters, 6 centimeters, and 7 centimeters. With also another line inside, which is 4 centimeters, we can see that our perimeter is equal to 5 plus 6 plus 7, and we don't include the 4 centimeters since it is not part of the borders of our triangle. Hence, our perimeter is equal to 18 centimeters. Now moving on to the area of a triangle. Suppose we have a triangle ABC. The baseline BC is called the base, and the line drawn from the apex A to the baseline is called the height. But for us to calculate the area, the height should always be perpendicular to the base. So, in case it is not provided, you can calculate it using the Pythagoras theorem. So, now if you have the base and the perpendicular height, then the area of the triangle is equal to half base times height. Let us do another quick example to show how can we calculate the area. Suppose we have our triangle ABC with base 8 centimeters and height 6 centimeters. We can use our formula. Area is equal to half base times height, which is equal to half of 8 times 6. Hence, the area of the triangle is equal to 24 square centimeters. Alternatively, there is another way to calculate the area of a triangle given two sides and an angle. Suppose we are given a triangle ABC with an angle theta and two sides A and B. We can then calculate our area using the formula half A times B times sine theta. And take note that A and B are the sides of the triangle, which makes the angle theta. Let us do the example together. If we have triangle ABC with sides 6 centimeters, 7 centimeters, and 8 centimeters, and also given the angle 30 degrees, we can see that the sides which are making the angle are 6 centimeters and 8 centimeters. Hence, these will be our A and B. So, now we can use our formula to calculate the area. So, if we substitute the values, we get half of 6 times 8 times sine 30, which will give us 12 square centimeters. Now we are done with the triangle. So let us now move to the rectangle. A rectangle has two equal sides, which are opposite to each other, and all the interior angles are 90 degrees each. The longer side is called the length, and the shorter side is called the width. Hence the perimeter is equal to 2 times length plus width. So let's do the example. We are given a rectangle with length 8 centimeters and width 5 centimeters. So, the perimeter is 2 times length plus width. If we substitute, we get 2 times 8 plus 5, which is equal to 2 times 13. Hence our perimeter is 26 centimeters. While still on the rectangle, let us also calculate the area. If we have our same rectangle with length and width, therefore, the area is simply length times width. For example, using our same rectangle with length 8 centimeters and width 5 centimeters, we can calculate our area using the formula length times width, which is 8 centimeters times 5 centimeters, which will then give us 40 square centimeters. We also have a special type of rectangle, which is called a square. The unique thing about a square is that all the sides are equal, which means the length is equal to the width, hence we just call it a side with symbol S. So, for the perimeter, we simply multiply the side by 4, hence it is 4S. And for the area, we multiply side by side, hence it is S squared. Let's do a quick example. Given a square with side 5 centimeters, we can calculate the perimeter using the formula for S, which is 4 times 5, and the result is 20 centimeters. Then for the area, we use the formula S squared, which is 5 squared, and the result is 25 square centimeters. Let us now move to our final shape, which is a circle. We will start by calculating the perimeter or the length of the circumference of a circle. So, if have a circle and radius r, we can calculate the perimeter by using the formula 2 pi r. The value of pi is normally given in your exam, but in most cases, you use the calculator. So, in all my examples, I will be using the calculator. So, let's do this example together. We are given a circle with radius 5 centimeters. So, the perimeter will be equal to 2 pi r, which is equal to 2 pi times 5. If we punch this on the calculator, we get 31.4 centimeters. Now, instead of calculating the length of the whole circumference, we can also calculate a small part, which is the length of an arc. So, if we have a circle with center O and radius r, we can draw another radius to make an angle theta, which corresponds to an arc AB. So, to find the length of the arc, we use the formula theta over 360 times 2 pi r. Let us do another example together. Given a circle with center O, with radius 5 centimeters, and also given another radius, which produces an angle 45 degrees, and the corresponding arc AB. We can calculate the length of our arc using the formula theta over 360 times 2 pi r. If we substitute, we get 45 over 360 times 2 pi times 5, which will give us 3.9 centimeters. Now moving to the area of a circle. Given a circle with radius r, the area of this circle will be equal to pi r squared. For example, given a circle with radius 5 centimeters, we can calculate the area by our formula pi r squared. If we substitute, we get pi times 5 squared, which is equal to pi times 25, which is equal to 78.5 square centimeters. Now, moving to the area of a sector. If we have a circle and 2 radii, which forms a part of the circle, called a sector AOB, with an angle theta, we can calculate this r by using theta over 360 times pi r squared. For example, if we have our circle with radius 5 centimeters, then we draw another radius to form a sector AOB with an angle of 45 degrees. We can then calculate the area of the sector AOB using our formula theta over 360 times pi r squared. If we substitute the values, we get 45 over 360 times pi times 5 squared, which is equal to 9.8 square centimeters. Lastly, we are going to discuss about the area of a segment. If we have our circle with center O, and given the radius r and another radius to form a sector, we can also add a chord from A to B and get our segment AB. And this segment corresponds to the angle theta. So, if we want area of the segment, we can start by calculating the area of the whole sector, then we subtract the area of the triangle. Hence, the area of the segment is equal to theta over 360 pi r squared minus half times r squared times sine theta. For example, if we have our circle with center O and given the radius 5 centimeters and another radius to form a sector, we can also add a chord from A to B and get our segment AB. And this segment corresponds to the given angle 75 degrees. So the area of the segment is equal to theta over 360 times pi r squared minus half times r squared times sine theta. If we substitute, we get 75 over 360 times pi times 5 squared minus half times 5 squared times sine 75, which will then give us 16.4 minus 12.1. Hence our final answer is 4.3 square centimeters. Now, this marks the end of the first part of mensuration, and the second part will be focusing on volume and total surface area for different three-dimensional shapes. Thank you so much for watching. I hope this video was very useful to you. And once again, if you have any comment or question, just feel free to type it in the comment section. And don't forget to like, share, and subscribe. I wish you all the best.